What's going on, y'all? This is the second video of our solving systems of equations unit for right now. And we're starting off with section 5.2. This is solving systems of equations using substitution. This is kind of when we start to get into the more, like when we get into more like the algebra side of how, like the more mathematical ways of how to solve these systems using of equations. So I can't really see it very well, but essentially solving using substitution. So essentially what we want to do is we want to solve one of the equations for a variable, and then we're going to substitute whatever that variable says into our other equation. Then obviously then we're going to solve the new equation, and then we substitute our answer into our first answer into any equation. Now I know that's a lot of words, and I know some people will be like, what the heck does that mean? Let's go ahead and show you, okay? So for this first example, we have a system of equations right here. We have x equals 2, and then we have y is equal to 4x plus 1, and we need to solve for, both x and y, all right? Now, we need to find a equation up here that has kind of a nice little, hey, x equals or y equals right there, equation right there. And it just so happens that we already have one of our equations right here already gives us that x equals 2, all right? So not only, that actually gives us one of the answers right here, that one of our answers is 2, because it already tells us that x is 2. Now, what we can do to find what y is, because we need to find both x and y, is we can take, because x is 2, we can plug in this 2 right there for x. So what we're going to do, we're going to get y is equal to 4, and then in place of an x, we're going to do 2. And again, this is 4 times x, so it's going to be 4 times 2 plus 1. So then we substitute that, we simplify down, we get y is equal to 4 times 2 is 8, plus 1, y is equal to 9. So for our answer, we're going to get that 2, our answer is 2, 9, all right? Or we could even write that our answer is x equals 2, y equals 9, okay? So that's our first, so that's a pretty solid basic example of substitution. Again, we basically find what x is equal to or what y is equal to, and we plug it into the other equation there. But what if we get to something a little bit more complex like this, where x is equal to 2y plus 3 and x is equal to 3y plus 20? So we want to solve one or both of these equations for a variable, but it just so happens that, hey, we already know what x equals to. We're already solved for x. We know that x is equal to 2y plus 3 and that x is equal to 3y plus 20. Now, because we know that, hey, both this and this equation are both equal to x, we could basically set both of these equations equal to each other, or we could basically substitute this in for this x right here, because we know that this equation is equal to x. So what I'm going to do is, since both of them are equal to x, they're both equal to each other, so I'm just going to set them all both equal to each other. So I'm going to get 2y plus 3 is equal to 3y plus 20. And then from there, we solve for y. We have to get all of our variables, our y's, on one side, and we have to move all of our numbers or non-variables to the other side. So plus 3, that's going to give me a negative 17, equals 3 minus 2, that just gives me y. So I know that negative 17 is equal to y in my final answer here. But that's not it. Now I need to take this negative 17, take it back up here to one of these y's, and plug it in order to get what x equals. So, and you can pick any of the equations. It doesn't really matter which one you choose. I'll pick the top equation, this one here, and I'm going to plug in negative 17 for y. So it's x is equal to 2 times a negative 17, because it's 2 times x. I'm just going to plug in 2 times y. I plug the negative 17 in for y, plus 3, and then from there I simplify. I do x is equal to 2 times negative 17 is a negative 34, plus 3, I'll get that x is equal to negative 31. All right. Oh, not quite. And that is my final answer right there. Okay. So that's a common substitution, that you'll see, where you basically get two equations, you might get two equations that are both x, oh darn it, where that are both x equals, or you might get two equations that are both y equals. And in order to solve by using substitution, you would just set these two equations on the other side just equal to each other. And if it's y equals, then most of the times you'll have an x over here. You'll solve for x, or in this situation, we would set both the y's equal to each other and then solve for y. So again, that's a very common substitution tactic that you will see, I will guarantee, many times going forward. Okay, so solve the system. We want to solve one of our equations for a specific variable, either x or y. It doesn't really matter which one. And again, it looks like, and again, when I say solve for a variable, what I'm talking about is I want to see a y equals or an x equals, all right? Just a y on one side of the equal sign or just an x on the side of the equal sign. And it just so happens that I have a y by itself on the equal sign right here. So I already have an equation that is solved for y. Now, what we do, if once we finally get this, where we get a y is equal to, or an x is equal to, like what we get over here, then what we do is we will take this equation right here, because this equation is basically y, and we're going to substitute, hence the name solved by substitution, and we're going to take this and substitute in for the y in our other equation, okay? So we're going to take this 3x plus 2, and we're basically going to put it in wherever we have a y at. So this is what I'm going to get. I'm going to get x, the x stays the same, plus 2, and then instead of a y, I'm going to put in 3x plus 2 to get 2 times 3x plus 2 is equal to 11, okay? And then from there, we distribute this out right here. We're going to get 6x plus 4 plus x, and then from there, we just solve for x, all right? We combine our like terms right here. X plus 6x gives me 7x. I'm going to move my numbers all to one side, so I'm going to subtract a 4 over. I'm going to get x, 7x is equal to 7. Solve for x, I divide by 7, and I'm going to get an x equals 1. So that's my x answer that's the x number for my equation. Now, remember what we do here is now we take our, we take our answer, x equals 1, and we plug it back in for any of the x's for both my two equations, all right? Now, you only have to pick one. If you want to pick both to make sure you have the right answer, you can, but you only have to plug it in for one. Because this second equation is kind of, nicely solved for y, I'm going to go ahead and plug the 1 in for there, because that's what I'm trying to find. I'm trying to find what my y value is, so that's what I'm going to do. So I'm going to use this equation, y is equal to 3, and instead of an x, I'm going to plug in a 1, and then plus 2, and then from there, I just solve for y. 3 times 1 is 3. 3 plus 2 is equal to 5, and that right there gives me the y value of my ordered pair there. So that is essentially my answer right there, 1, 5, or if you wanted to write in x equals 1, y equals 5, you could do that as well. All right, but again, these are the answers right there, okay? All right, so going on to another one here. So now this one looks probably the most complicated one we've done all day with this video, but now this one involves a few more steps. But once we get to after those steps, then it basically turns into same problem we've been doing. So again, we want to get an equation that looks either like this or like this, where it's an x, just an x equals to, or just a y equals to, all right? That's what we're trying to go for here. So what we need to do is we need to pick one of our equations, I'm going to label them 1 or 2, to solve for either x or y. And what we notice with this first equation is that we could add this 2y to both sides, and we can get that x equals -6 plus 2y, henceforth giving us the x equals and then whatever's on this side, all right? Now, You could go the more complicated route. You could solve for this y, or shoot, you could even use this equation to solve for x. But whenever you're using substitution and you see this x, like a single x right there, that's the variable that I recommend you solving for, because that's going to give you the easiest numbers to work with right there. Because the rest of these are going to deal with, fractions, and I know that nobody here really likes dealing with fractions. So now, since I have my x equals negative 6 plus 2y, I'm going to take what this x right here, and for all my x's in my other equation, I'm going to substitute this in for that x. So let's go ahead and do that. It's going to be 4, and then instead of an x, I'm going to put in my equation right here, negative 6 plus 2y, plus the 6y doesn't change because I'm only substituting in for the x, is equal to 4. Now let's go ahead and simplify out. I distribute this out. I get a negative 24 plus 8y is plus 6y is equal to 4. I combine these two together. 8 plus 6 is equal to 14y. I have to move my numbers to one side, so I'm going to add the 24. I'm going to get 14y is equal to 4 plus 24 is equal to 28. Now I solve for y. I divide the 14 on both sides. And I'm going to get that y is equal to 2. All right. And now what I remember I need to do is I need to take this 2 and I need to plug it in for my y value in either my first equation or the y value for my second equation. Okay. And normally in this situation, what I would do is choose the value that is, choose the equation that looks easier for you to work with. For me, I'll use that first equation. So I'm going to use the first equation. I have an x minus, and I'm going to plug in my numbers for y, which again is 2. So I'm going to, instead of negative 2y, it's going to be negative 2 times 2 equals a negative 6. And so from there, I'm going to go ahead and simplify. It's going to be x. Negative 2 times 2 is minus 4 is equal to a negative 6. I'm going to add the 4 on both sides. And I'm going to get that x is equal to a negative 2. And there, right there is our final answer for that system right there. All right, so let's go ahead, and I think this is the last example for this video here for 5.2. And let's go ahead and solve this system by using substitution. So again, I am looking for an x equals or a y equals. So right off the bat, I don't see that immediately with my equations. So now I need to go ahead and do some, move some stuff around to do that. Now, label my equations 1 and 2. Yeah, this is just something I kind of do. You don't have to do that, but it's just something I like to do. And you want to look for a singular x, kind of like this one, or even a singular y, like this one, to solve for. Now I already have this positive y right here. So what I'm going to go ahead and do is add the x to both sides, all right? Because again, negative x, I get rid of the x on this side, just add x. I add the x to both sides, I get y is equal to 6 plus x. So now I have that y is equal to, just like what I did over here, now what we need to do is take this y and plug it in for all of our y's in our second equation there. So it's right there. So what I'm going to do, I'm going to say negative 8x, I don't change my x's, plus 4, and instead of y, I'm going to substitute in my 6 plus x right there is equal to 24. From there, we simplify out. 4 plus times 6 is equal to 24. 4 times x is just 4x, plus a negative 8x is equal to 24. We move our numbers to one side. And 24 minus 24, we add our x's together. We're going to get negative 4x is equal to 0. And then if we divide by negative 4, hey, we get that x is equal to 0. Look at that. So that's the x value of our answer there. Now we need to find the y. And again, remember, we take our x value and we can plug it in for both the x in our first equation or the x in our second equation. Again, I recommend use the equation that you look most comfortable using. So let's use that second equation. So I'm going to write kind of the second equation over here. We plug in, instead of a negative x, it's just a negative 0, which is literally just 0. Plus y is equal to 6. 0 plus y is equal to 6. 0 plus y is just y. So we get here that, y is just equal to 6. And that right there is our final answer. Okay, so that is essentially solving systems by using substitution. We will get the next video up real soon. Thank you guys for watching.